Okay, so we're going to pick up in the middle of this section about ionic compounds. We looked at naming binary ionic compounds, which have a monatomic cation and a monatomic anion. So just a single element like chloride or something. Some ionic compounds have polyatomic ions. And I asked you to memorize a bunch of these already, so these should be familiar. Pardon my cough drop. So the names and formulas of the polyatomic ions follow some patterns, but the bottom line is you just have to memorize them. Like you memorize the alphabet, right? Or numbers. So when we name an ionic compound that has a polyatomic ion in it, we follow the same pattern as naming one that just has a single monatomic anion. We name the cation first, and then we name the anion. So NaNO2, the first ion is the sodium ion, and the second one is NO2, which is nitrite. What is important to remember is that in Chem 1A, there's always just two ions. Sometimes students want to separate this and say there's a sodium ion and a nitrogen ion and an oxygen ion. That's not correct. Okay, in Chem 1A, there's always two ions, one cation, one anion. So when you look at something like this, it's got all these different letters in it. The first the first element, Na, that's the cation. So cover that up. Everything else is one thing. Okay? If it's more than one capital letter, it's got a special name. If you don't remember what it is, look it up. So a good strategy when you're naming things like this is try to remember the name or the formula of the polyatomic ion and then check. If you always just go look it up, you're never going to get a good mastery of what they are. So these are the most important ones. On the list to memorize, there were some others, but these are the most important. And there are some patterns here. You'll notice that all but one of these are anions. There's only one positive, I can't get down there, ammonium way down there at the bottom. That's the only positive polyatomic ion that we're going to learn about. Most of these have oxygen. The oxygen is generally listed after the other element. And so we've got things like nitrite and nitrate. Their names are similar and their formulas are similar. Couple of odd ones. We've got cyanide and peroxide and hydroxide. I think all the rest of them end in either ate or ite. If it ends in ate or ite, it's got oxygen in it. So if it's got oxygen in it, it's called an oxy anion because it's an anion containing oxygen. And that's what most of these are. So there are some series of oxy anions with the same element, so like the nitrate, nitrite. When there's two ions in the series, there's a pattern here. The one that has more oxygen atoms has the ending ate, and the one with fewer has the ending ite. So we can see nitrate and nitrite, sulfate and sulfite. The difference between these pairs is one oxygen. The number of sulfurs or nitrogens is the same. The charge is the same. The only thing that changes is the number of oxygens. So there's a pattern here. So here we've got chlorate and chlorite. And if we have one more oxygen than chlorate, we call it perchlorate. And one less than chlorite is called hypochlorite. So there's a series of 4 related oxyanions for chlorine. And there's a very similar series for bromine, and there's a similar one for iodine. The difference between bromate and chlorate is you change the chlorine for bromine. And the relationships with the numbers of oxygens are the same. So this is how I think of it. You memorize what I call the ates, all the ions that end in ate. So chlorate, sulfate, phosphate, nitrate, those guys. And then you learn this pattern. So you memorize this one. If you need perchlorate, you take that and you add one oxygen. Because per is a prefix that means more. Like hyperactive, right? That means you're more active than regular people. So perchlorate has one more oxygen than chlorate. Ite is like the light version. So there's Bud and there's Bud Light, right? Bud Light has a third fewer calories than regular Budweiser, right? These commercials. I don't drink this stuff, but I still know that, right? Good advertising. The light version of chlorate has a third fewer oxygens than regular chlorate. See that? So there's chlorite, the light version. You just take the 8 and you subtract 1 oxygen. Charge stays the same. And then there's hypochlorite. Hypo is a prefix that means below. Don't want to creep you out, but where does a hypodermic needle go?
Under the skin.
Under the skin, below your dermis, right? Below dermis, hypodermic. So this is 1 fewer oxygen than the chlorite. So I think this pattern is pretty easy to remember. And so then what you have to do is make sure that you've got those 8s down pat. Okay? Sorry. Any questions? And this note here, I list these upside down of how the textbook shows it because it makes more sense to me to have more oxygens at the top and fewer at the bottom. It gets smaller as you go down. But that's just how I think. No questions? Okay, so let's practice. Let's name this compound SnClO3 So we're only doing ionic compounds for now, but we're going to get into others. So let's remember how to identify an ionic compound. We look at the first element. The first element is Sn. And regardless of whether you remember its name or not, you can find it on the periodic table. Is it a metal or a nonmetal? It's a metal. So metal, ionic compound. So we've got 2 ions here, the tin and the rest of it. So if it helps, you can draw a line here. You got 2 things. So we name the first one, and then we name the second one. So I already gave away the element name for Sn. That's tin. Does tin need a Roman numeral?
Yes.
Yes. It's not in groups 1A, 2A, 3A, zinc, or silver. It needs a Roman numeral. So I'm going to put parentheses here because I don't know what that is yet. I'm just going to save space. And then we have this, ClO3 in parentheses with a 2 on the outside. So what's up with that? Well, inside the parentheses is the formula for a polyatomic ion. I think of the parentheses as being a little bit like shrink wrap, and then on the outside, this 2 tells us how many of those groups we have. A little bit like shopping at Costco. You can't buy 1 bottle of ketchup, right? You only buy 2 bottles, and they're shrink wrapped together. So this chlorate, oops, gave that name away too. This chlorate, ClO3, is a unit. You can have 1 of them, or 2, or 3, but just like at Costco, you can't break it up and just have part. So this is telling us that we have 2 of those units. So the parentheses and the number outside are not related to the name of what's inside the parentheses, just name what's inside. So what we have inside is ClO3, and it's got a charge. What's the charge on that ion? -1. How do you know that? How do you figure that out? You memorize it, okay? Then we need the name of this. Chlorate. Because you memorize it, right? So this is chlorate. So we've got the names of those ions except for the Roman numeral. Remember, the Roman numeral gives us the charge on the cation. Because tin can have more than 1 charge. And what we're going to do is we're going to look at the charge on the anion. Let's draw it out over here. So I've got, that's messy, ClO3, and the parentheses with the 2 tells me I have 2 of those ions, and I have 1 tin ion, and I don't know what its charge is. But when I put these guys together, their charges have to add up to 0. So what's the charge on the tin? 2. It's plus 2. So then the charge is 2. I put the Roman numeral 2 in the parentheses, and there we have the name, tin 2 chlorate. Any questions? So going the other way, write the formula, here's the name. When you're writing formulas, until you get really good at this, you need to write each individual ion with the charge and then put them together to make the formula for the compound. So cobalt 2. Well, we need the symbol for cobalt, CO. And what does the 2 tell us? It's the charge, 2 plus. It doesn't mean that there's 2 cobalt ions. That's an easy misconception, but it is a misconception. And then phosphate. What's the formula for phosphate?
PO4 3 minus.
PO4 3 minus. Because you memorize it. Okay, so we need to figure out how many cobalt 2s and how many phosphates so that when we group them together, their charges add up to 0. We've got plus 2 and minus 3. Those are not the same, so we could do the crisscross thing. Or you can say, well, what's the least common multiple of 2 and 3? It's 6. I need 3 cobalts and 2 phosphates. There's multiple ways to think about it. We should all arrive at the same answer, though. So we're going to have 3 cobalts. Very important to make sure that that O is a lowercase o. Otherwise, it looks like carbon and oxygen. And we need 2 phosphates. So PO4. If I just put a 2 here, kind of looks like 42 oxygens, right? You can see how that would be misunderstood. This is one of those multi-packs at Costco. When we have more than one, we put parentheses around it, and we write the number on the outside to say how many of those groups do we have. You don't need the parentheses if there's only one, because it wouldn't be confusing. You don't need parentheses if it's a monatomic ion, because it wouldn't be confusing. If we're looking at calcium chloride, this is telling me there's 2 chloride ions. But chloride ion is a monatomic ion. It's not confusing, so we don't use the parentheses. If I've got something like sodium hypochlorite, well, that's not a good example. Barium hypochlorite. No, that was the example I wanted. I don't know what I'm saying. Well, that one's okay, but sodium hypochlorite, we don't need parentheses because there's only one of these ions, okay? We don't want to write extra stuff, but we want to be very clear about what we're suggesting. Any questions? So any questions? Hydrated compounds. So the word hydrate, what does that refer to? Water, right? When you're dehydrated, your body doesn't have enough water. You need to stay hydrated, right? You have to have enough water. So hydrates are ionic compounds that have water molecules associated with them. Now this is different from just a wet substance, right? These have a specific number of water molecules that are incorporated into the crystal structure of these compounds. So here we have cobalt 2 chloride, and this one, for every formula unit of cobalt 2 chloride, there are 6 water molecules associated with it. It's always the same, and so that's a compound. It's not just something that's damp, has some water in it. If we heat this, we can make the water leave, and we have what's called anhydrous without water, anhydrous cobalt 2 chloride. We see that the color changes, and that often happens. So the names for these, you name the ionic compound the regular way, and then there's a dot, which does not mean multiplication. Okay, that does not mean multiplication. It just means that these two go together. There are 6 waters, so we use a prefix for 6, which is hexa, and then hydrate for this, for the water. So Epsom salts are something you use to soak sore body parts in, like your feet or something, or a sprained ankle. Magnesium sulfate and 7 waters, so it's heptahydrate. So that's this systematic name, magnesium sulfate heptahydrate. The common name is Epsom salts. Don't ask me why, it just is. And I already talked about that one. So these are those numerical prefixes I mentioned. And we're going to use these for naming molecular compounds as well. So mono, di, tri, a lot of these are very similar to things you may have learned in math. How many sides does a pentagon have? 5. Penta is a prefix that means 5. Tetra's one you might not have heard of before because in math you call it a square, not a tetragon. But tetra means 4. Hepta's kind of weird, that's 7. Octa makes sense somehow. An octagon, I guess. Nona is like 9, and deca is a decade, 10. So let's practice. Let's name these guys. Hemi's weird. Hemi's half. So if I'm going to name this hydrate, I'm going to name the ionic compound first. So what's the name of the cation? Calcium. Does it need a Roman numeral? No, because it's in group 2A. Calcium. No Roman numeral. And so then we're going to cover up calcium, and what's the name of the rest of that? Sulfate. So calcium sulfate. And then we've got this dot 1/2 H2O. So the prefix for 1/2 is hemi. So this is hemihydrate. Now surely someone has a question about that one. How can you have half a water molecule?
It combines 2 of the name.
Exactly. So this is written, what it really means is we've got 2 calcium sulfates for every 1 water molecule. But by convention, we always write ionic compounds in their lowest form. And so to do that, then we have to put a 1/2 here. It is not implying that there's half of a water molecule. But there's 1 water for each 2 of these. It's not going to come up often, but I just want you to be aware. How about this one? What's the ionic compound's name? Calcium chloride. So we already established calcium doesn't need a Roman numeral. Chloride. I don't need to use any prefix like di or anything for that because it's the charges in the ionic compound that tell us how many. So we're not using these prefixes, as lovely as they are, we're not using them for the ionic name. And then we have dot 2H2O, so what would that be? Dihydrate. How about this one? Barium hydroxide octahydrate. What's the formula for the barium ion? Ba with what charge? 2+. And what's the formula for the hydroxide ion? OH negative, because you memorize it. We need to have the ion formulas with their charges, because then we look at the charges and that tells us we need 2 hydroxides. So that's 2 of a polyatomic ion. We put it in parentheses, put the 2 on the outside. Octa means 8, so dot 8 H2O. Barium hydroxide octahydrate. Any questions?